Coming up on the FTC Open Alliance Show, 23513 I.N.T Robotics from New York City is on with their incredible custom-built robot. From a carbon fiber arm to CAD overview, this team is treating their first qualifier like it's already Worlds. We got so much to dive into with this robot, including how they're tackling April tags, with their post estimation, and so much more. You're going to love this robot and their progress so far, so let's get ready for the FTC Open Alliance Show. This video on fun is brought to you by viewers like you and also in partnership with the following. Studica Robotics is everything your team needs to build, learn, and compete. Check out their FTC Starter Kit, Intake Hub Kit, and odometry wheel options at studica.com/robots. Teams in the USA can get up to 25% off and apply for grants at studica.com/robots. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. And up next on the FTC Open Alliance Show is 23513 I.N.T Robotics coming out of New York. Darius and Andrew, welcome to the show. Why don't you guys introduce yourselves a little bit more? Let us know what you do on the team, and we have so much to jump into today.
Yeah, so my name is Darius. I'm one of the team captains for I.N.T. What I mainly handle is programming and electrical.
My name is Andrew. I'm the other co-captain of I.N.T, and I work on CAD design and mechanical.
So we got to talk about right away this robot that you have in front here. I mean, this is so cool. What you have all been doing, carbon fiber arms, custom machining and stuff. We got a lot of great stuff to cover, but let's jump right into your robot.
Sure. So I think we should start from the beginning with this. So robot, in 2 days, we had over the weekend event at Kickoff where we wanted to create a unique robot for this year. And we remembered that we had the carbon fiber arm laying around and we thought we'd give it a shot. So we actually have it down here. And this is it in its unspooled version, or its spooled version, where it's just sitting as a small spool right now, not open. But then we're able to have the ability to unspool it and open it up. And this one actually extends 9 feet. And that's obviously not legal for the FTC game this year. But using software limits, we're allowed to make this legal and use it within the match and competition. So as for the mechanism, we have this right here, which is our custom gearbox that we've created. So this is a 3-motor gearbox. 2 of them are driving extension. 1 of them drives the pivot action, and it's in a custom aluminum casing that we CNC'd here on the ShopBot. And pretty much the main benefit that we have from using the custom gearbox is that we're able to keep all of our motors on the bottom of the chassis. So when it's mounted, it would sit inside this slot that is nice in the back of the robot, and the motors would be down on the bottom of the chassis, keeping our center of gravity low to the ground, which helps for driving and helps for hanging as well, which is part of our hanging sequence.
I want to take a quick step back here. Why, for your team, was it so important to go custom routes for things? I mean, there's so many COTS options out there. Talk to me a little about some of the thought process behind that, and maybe what your team has learned, and any advice for other teams looking to do the same thing.
Right. So our goal for our first qualifier is we wanted to have a fully custom built robot that we would also be able to take to something like New York City Championships. And we really wanted to push out a high quality and a high competitive robot really quickly in the first few weeks of competition. And that's what we've really been aiming at doing. And that's how we got to this point where we went with the full custom build. And as for not using COTS parts, the reason we do it is because we have so much more freedom with 3D printing, CNCing, and using all of the materials that we have to our advantage when it comes to creating a fully custom robot. For our last year's robot, we used a lot of COTS parts and we encountered many issues. And then this year's robot, we have fixed these issues by not using and not relying too much on COTS parts, and actually creating them all from scratch, mostly being 3D printed for things like the claw over here. So this claw is fully 3D printed. Even the wheels are 3D printed, and they're actually rubber dipped. And we have it's a 2-axis claw, so we can rotate the claw like this, and then also pivot backwards like that. Then we also have the other 2 servos that drive the power to the wheels that will intake the game piece.
And another tip that's maybe more applicable for teams, just as a general concept to keep in mind while going throughout the season, is that we're treating qualifier 1 as if it's our local like New York City Championships, which is why we're stressing over deadlines as if it's our last competition before Worlds, we're stressing over building the robot, getting things done and tested, because then by the end of qualifier 1, no matter what the result is, win or lose, whatever awards we got, we put our heart and soul into the first iteration of the robot, and we know exactly what we have to iterate and ideate on and improve for the following competitions. And that's how we ensure that we can have like a championship level robot way before championships actually rolls out.
Yeah, I love the thought process behind that. And obviously, consistent iteration throughout the season will see you improve even more and more. But I love your approach to how you're going about that. Anything else on your robot that you wanted to cover from here, or should we jump into your CAD?
I think we can go into the CAD. Most of it is here, and then we'll pretty much preview everything in the CAD.
Sure.
So to start off, the chassis right now is over here without the main mechanism on it, and we made it so that we can actually take the mechanism off and on and off really easily by just having mounting points along this base plate that we actually CNC out of aluminum. So the base plate pretty much holds everything together, and this allows us to use these brackets on either side of the main mechanism that allow for easy access of putting on and taking off the main mechanism, since that main mechanism is our entire robot pretty much. Pretty much it allows us to climb, it allows us to score the samples, and we have our intake mounted on it. So that main mechanism is very important to be able to take on and off for maintenance easily. And we also need to be able to have easy access for wiring. So we've added routing holes throughout all of the pockets of our aluminum and even our polycarbonate on the outside. And another cool thing about this robot is we've actually tried to introduce a lot of electronics this year into our robot, which we can go over now.
Yeah. Okay. So and you can outline these things as we go in the CAD. But as he was talking about earlier with the polycarbonate pocketing, we saw one thing that we're doing this year that we didn't do last year in the CAD is that we're integrating the electronics into the CAD. So the first thing that we did is that we took into account, three core things, which is the control hub, the expansion hub, and the battery and its associated battery switch. So you can see on either side, you have one side for the control hub, the other side for the expansion hub. And if you look at the exterior polycarbonate plate, it's pocketed in such a way that my fingers, as someone who has to do electro and has to plug in all the wires, like I'm doing it right now physically on the robot, all the access points are really easy to reach. If I ever need to unplug a motor, swap out an encoder cable, I can do it with relative ease. Everything, like pretty much every piece of electronics that we're going to use has been CAD at one point. For example, like the servo power module is up top here. We have one of the what I consider the most important things after going through a couple of inspections at competition is knowing where our power switch is and making sure that we have a visual representation of it on the CAD, so we know its legality and whatnot. And because we already had it placed out in the CAD, when we actually got to it on physically assembling it, we know that it's a location that makes sense. Referees can see this; they know that there's good access, and we have to stress less about the inspection process, especially for electrical, because that tends to be the most finickiest part about it. But I just really like, especially as someone who has to manage the electrical on this robot, it makes everything so much easier to troubleshoot and to actually get assembled and disassembled.
Everything that's gone, I love just the thought process of what has made this happen. What are you using for your CAD software, by the way, just so everybody knows?
So we're using Fusion 360, and we have some members that use Onshape as well. So when it comes to things like machining, we have to actually transfer files to Fusion 360 from Onshape, but we do most of our CAD on Fusion 360.
Yeah, because Fusion 360 also translates really nicely into machining. I'm a really big fan of their manufacturing environment. It makes it the CNC machine that we use the ShopBot, and it makes it really easy to just get it set out. We can post process a bunch of G code and overnight or however long it'll take, and it makes the process much more smoother.
I want to ask you real quick, when we were talking pre-show, you mentioned that you have students on your team from all different boroughs of New York as well. How is your communication, or how does your communication method work? Can you break that down a little bit more? Because if you have some people working on Onshape and they're somewhere else, and you're working on Fusion 360 somewhere else, or just all the other things, how are you communicating and making sure everything's streamlined for your team?
All right, so I guess it would be good to talk about our general communications platform, and then Andrew could go more in depth on how we communicate for CAD related things. So personally, we have a Discord server. That's where, and we have a bunch of different channels for programming, for electrical, for design, for general, all that type of stuff. The usual Discord FTC team setup. But in there, like I know me personally, if there's ever something like an electrical part that needs to be ordered, I can make a note of it in the chat, and the other team members, they can see it. Every time, usually at the end of the day, if we make any significant like CAD modifications, we usually post a screenshot, and Andrew will post a reminder saying like, oh, this thing just got worked on. If someone else on the team needs to pick it back up because someone can't make it, usually the communication flow actually isn't that bad, because I know that we don't all go to the same school. Like, for example, Andrew lives in Queens, I live in the Bronx. Because we all work out of the same communal lab, not only do we see each other in person and we can update each other there, but we communicate I'd say daily. Pretty much there aren't many days where we don't talk on Discord and one of us don't know what's going on. But delving a bit deeper into that, Andrew can talk about the actual specifics of the Fusion team and stuff like that.
Yeah, so we developed a Fusion team where all of our members have access. So even the members that use Onshape, they still have access to our Fusion team where they can see the CAD models, and we upload everything there so they can see the claw design. They can see the first iteration. They can see the newest one. They can see our drivetrain from where it began and where it is now. And even though some members use Onshape, we do like weekly calls with them where I'll do a call with them where we'll both work on different parts of the robot, and then we'll work on integrating them together. And when it comes to machining, as you said, the camming on Fusion 360 allows it to be much easier for us to actually machine them in-house. And pretty much as for communication, since we don't live in the same area, we don't go to school in the same area, we come to one main spot, which is on Roosevelt Island. And where we work here, it's a STEM space, it's a maker space. So we all have access to machines here, and we all have access to laptops where we can communicate easily in person and CAD together.
There's a lot of great stuff that your team has going on from a software side. Once again, reading through your blog on Cheap Delphi, you had as well too. Love to see that your team is utilizing the April tags this year, like many teams are. But you have some really great process to go through and some cool demos and videos as well. Why don't we break down some of these as well too and what you're doing?
Yeah. Okay. So if we're gonna talk about more software stuff, let's sort of do this in chronological order. I'd say the first like major thing that I worked on was probably during Robot in 2 days. Because one thing I noticed is that I already knew that April tags were going to be like an important part of this year, whether it be for teleoperated processes or autonomous, because that's how big of a deal a role it played last year in my like autonomous, odometry, whatever routine pathing algorithm I was working with. So that was like the first thing I wanted to get out. Actually, the first that was where I encountered my first roadblock is that in the FTC SDK that people use through Android Studio, they usually like the people who like release the official release, they usually have a library for April tags and stuff like that, because it should have their position on the field, like their coordinates, X, Y, inches, how many inches is it off the ground, off the mat, like its height, stuff like that. And I noticed that it wasn't released yet. So I didn't want that to like stop everything I had planned, because I already had a lot of deals like coursing through my mind. So I decided it couldn't be that hard. So I wanted to see if I could recreate it and make my own. So I did a little bit of reverse engineering, and I saw how exactly it was made in the SDK. And, setting up the Java class for it, the state isn't really that hard. The problem that I personally encountered, because it's pretty easy to like measure it up on the field, because also the manual tells you like how far off it should be from this mat, so you can pretty easily pinpoint X, Y, and Z coordinates from that. The harder part was that there was an angular aspect to it, because the way that the field coordinate system works in FTC is that it has its own like origin frame based off of the red and the blue lines, and based off of that, all the April tags, at least in the game, at least in the SDK like database, it's all rotated from a certain amount, and they use quaternions to do this. And until Robot in 2 days, I did not know what a quaternion was. So I did my own research on it. I had a mentor who was very capable in math, and he taught me the ropes. And basically, like the most in layman's term, a quaternion is literally just a 3-dimensional vector that has the X, Y, and Z components, and then it also has a real component, sometimes called W. It's like user preference, and that defines the magnitude of the vector, or actually the magnitude of the rotation that you're applying based off of that vector. So we did a lot of reverse engineering. We found a quaternion I found a quaternion calculator online, and I used that to see how far off were each April tags rotated from the field's like origin frame, which by the way, they didn't really tell you. So I had to find that out first. And after I found it out, I was able to get everything sorted, and I tested it out with some math. Because the end goal for all of this is that I want to have a camera that looks at an April tag during autonomous, during teleop, whatever it is, and I want it to tell me what is my position on the field in XY coordinates and also my rotation. Because I already know during autonomous, a whole bunch of different things can happen. I can get hit by another robot. There's slippage. There's inconsistencies between field A, field B, 1 and 2. However, however it's set up at competition. So I want something that can be referred to as almost an absolute like relocalization system. And this produced like very suitable results. And I think the two biggest things, the two things I'm most proud of in this accomplishment is one, as soon as it was done, I'm pretty sure like the night of, I open sourced it. I released it on the GitHub that was linked in the Open Alliance. So I actually had this released out before the official release even came out. And the second thing is that what this meant is that now every time I go to a competition, I can go to the field, I can measure what it actually is, and based off of those offsets that are presented to me in the real competition environment, I can modify my op modes to be reflective of what's actually before me. Because you can't really, it's not realistic to expect people to be able to set it up the same exact way that it is listed in the manual. So I just want to be accounting for everything. And with the video you just showed, that was another thing we worked on. That's a ArduCam on a swivel. We want to have sort of like a camera on a turret idea, because we saw that the biggest thing, one of the biggest issues I noticed with the April tags this year is that they're not really put in easy locations. Like last year we were a little bit blessed because the April tags were right under the mosaic board, so it was really easy to align, it was really easy to look at them. Now they're not really put next to any like significant scoring locations, so we had to make a few design modifications based off of this. Like for example, if we turn the robot bit here, you can see that we designed and printed this custom ArduCam mount specifically to the right of where the front of the robot is, because we noticed in the configuration that most robots would be to score into the buckets, you would have the right side of your robot always facing one of the April tags. So that's the case. This is the camera work we plan to use for alignment and also relocalization during the whole scoring process. And to those ends, since we knew that all of the April tags are on the borders of the field, they're not on any actual game pieces, we want to always have at least one April tag in view while we're doing any teleoperated or autonomous process, which is why I developed the code for the swivel to make sure that we can always be looking at an April tag. And the best part about it is that, as you showed earlier in the video, when you go too far away from an April tag, or you get closer to one April tag over the other, the camera knows it based off of where your X and Y coordinates, and it'll adjust to that and start looking at that. That's a little homage to things that FRC teams do with their turret, where auto aligns and always tracks the April tag, like how we saw this year, how we saw in 2022 in Rapid Reacts. So yeah, that was the sort of the initial software progress for Robot in 2 days.
So what are kind of next steps for your team, looking as you get ready for your qualifier event and you want to start moving forward? What are kind of like the next immediate things your team's going to be working on coming in the next couple of weeks?
So right now we're kind of in like a revision stage where we're pretty much improvising new like ideas and trying to figure out most efficient like methods of completing the tasks, because we have things that work. We have the carbon fiber mechanism works. We've seen it in the videos that we posted. We have the drivetrain that works. We have the entire robot can harmonize itself and work well, but we want to take it to a further step. We want to advance it as much as we can, and we want to go over finding out new innovative ways that we can create a more efficient robot. So recently what we've done is we've been using these new plates that we have here compared to our old polycarbonate plates, and these are out of aluminum, and we're actually using different bearings than we would use before, and we're using different methods of pretty much having a guide for the carbon fiber arm. So that's been one of our biggest challenges, is finding a way to guide the arm nicely and smoothly without overloading with friction, because sometimes when the spool is sitting in the back and you have a heavy weight such as the intake on the far end, it'll try to take the path of least energy, and that sometimes is just to unspool inside of the robot itself. So we're trying to find ways to account for that by using bearings to have the arm glide across, and using like pretty much long rollers that go across these. So there's two of these plates, and having long rollers that go across both of them so that the carbon fiber spool can freely glide when it's opening and closing.
Yeah, and so a little bit more on the software side of where we're looking to go next. What I've like accumulated over the past few weeks is a lot of proof of concepts. I've tested a lot of things individually. For example, there's the one video of the claw alignment logic. That one I just tested with a regular camera. I initially planned to do it with a limelight, but one of the methods wasn't working. I even emailed them and reached out to them because I noticed that other teams were having similar issues and they never got back to me. So I didn't want to wait on them. So I just like found an old web camera that we were using last year. And so I just made my own OpenCV program to recognize the contour of the rectangle. And so based off of the degree offset from horizontal, we know like how much to turn to it. And actually the class that handled that math was linear interpolation class that I made freshman year, because it was supposed to be for our shooter for Rapid Reacts, but and I never got a chance to use it until now, like 3 years later. So I'm happy that worked out. But for example, what I'm trying to get at is that this camera, which we've been using to do that alignment logic, we want to be able to design a mount in accordance with the current intake situation, so that we can couple these together and have everything mesh really nicely together. Because as you can see, there's a lot of things that work by themselves right now, but wouldn't work if we put them all together on the robot. Because as Andrew was talking about earlier, just with the whole hooks and the whole climbing sequence, if you look at the video where we have the climb test on the field, you see that like all the individual proof of concepts work. Our motors have enough torque, like when our carbon fiber arm is extended and if it was hooked on, it can pull the robot up. We can pivot ourselves mid-hang to adjust for the angle to go all the way up to level 3 hang once we have everything working. And the hooks can hold the robot. It's just a matter of figuring out like, oh, where exactly on the arm or the claw do we want to put on the hooks so we can grab onto it? Do these hooks at the top of our custom machine plates, do they have to be modified? Do they have to be shortened? So like Andrew said, we know that everything works individually. It's just the way it's just our task right now is figuring out how can we best mesh them all together.
Just going back to like the robot real quick. So as I mentioned earlier, we were talking about we want to integrate a lot of new electronics. Some of them being these new LED light panels from Gobilda, and using these to actually help the driver a lot, because we want to automate the driving sequences as much as possible. And we want to use these indicators as to know where if there's something inside the claw, if we're good, it'll be green. If we're missing, it'll be red, something like that, where the driver can easily see how the robot is reacting to the game elements. And having automatic sequences of going to pick up from the submersible and coming back to score on either of the different areas. Also, we've tried out a new odometry computer, which we haven't had the best of luck with too far.
Yeah.
So.
Well, 23513, first off, thank you for everything you've provided so far. There's a lot of great things I think teams can learn from this. Congrats on your success so far, too. I mean, this is incredible, the progress that your team has made. So we can't wait to see how you do in your first qualifier for it coming up soon. Make sure you do follow 23513 and their blog that they have over on Chief Delphi or on the FTC Open Alliance website as well, too. So can't wait to see how you guys do. Thanks a lot for taking the time, and good luck the rest of the season.
Thank you.
Yeah, thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Studica Robotics is everything your team needs to build, learn, and compete. Check out their FTC Starter Kit, Intake Hub Kit, and odometry wheel options at studica.com/robots. Teams in the USA can get up to 25% off and apply for grants at studica.com/robots.